Hey, my name is Altobelli, and this is my grade 12 Calculus and Vectors CCT. The purpose of this is to be an instructional video that gives you a thorough and detailed explanation of how to solve a problem. The specific problem that I was given was page 140, question number 18. The question is, the mass in grams of a compound being formed during a chemical reaction is modeled by the function m of t equals 6.3t over t plus 2.2, where t is the time after the start of the reaction in seconds. A says determine the rate of change of the mass after 6 seconds. B says is the rate of change of the mass ever negative? Explain. This question deals with rate of change and first derivatives, which shows how it clearly relates back to the second unit of our studies. The question asks us to find the first derivative at 6 seconds. It also asks us if the mass could ever have a negative rate of change. In the McGraw-Hill-Ryerson textbook, these concepts can be found in Chapter 2, Derivatives. The basic concepts can be found in Lesson 2.1, Derivative of a Polynomial Function, and more specific concepts can be found in Lessons 2.5, Derivatives of Quotients, and 2.6, Rate of Change Problems. In our notes, these concepts can be found in Unit 2, Derivatives. Lesson 1, Derivative of a Polynomial Function, Lesson 4, the Quotient Rule, and Lesson 7, Application to Science. Part A, it says determine the rate of change of the mass after 6 seconds. The important pieces of information we need to know are what is given and what is required. What is given is the general function and the variables. The variables being mass, m, in grams, and time, t, in seconds. What we're to determine is the rate of change, or slope, which could also be the first derivative. The question asks us to find the rate of change, or the instantaneous slope of the function, at 6 seconds. In general, the first derivative will give you the slope of any point on a function. Since I know this, my plan is to use the quotient rule and find the general equation for the first derivative. I will then use that and sub in a value of t equals 6 to solve for 6 seconds. Since the original chemical spill function that we are given is a quotient, we must use the quotient rule to solve for the first derivative. First, the quotient rule breaks the formula down into f of t and g of t, which we can see is 6.3t and t plus 2.2 respectively. The quotient rule states that if m of t equals f of t over g of t, m prime t equals f prime t times g of t minus f of t times g prime t, all over g of t to the power of 2. We know f of t is equal to 6.3t. We know g of t is equal to t plus 2.2. We don't know f prime t and g prime t. This is what we must solve for next. First, we'll solve for g prime. If we know the general form of g is x to the power of n, with x being the variable and n being the exponent, in this question, our x value is t and our n value is the exponent 1. The constant multiple rule tells us that any constant multiple does not get factored into the derivative. We can now use these numbers and variables to rearrange and solve for the derivative. We now have t to the power of 0, which does not exist, leaving 1. Therefore, g prime is equal to 1. To solve for f prime is much the same with accounting for the coefficient. The general form of f is ax to the power of n, with a being the coefficient, x being the variable, and n being the exponent. In this question, the a value is 6.3, the x value is t, and the n value is 1. Again, use these numbers to rearrange and solve for the derivative. Again, t to the power of 0 does not exist, leaving the remainder of 6.3. Now that we have solved all 4 values needed for our equation, we can sub them back into our equation and find the first derivative of our function. Now use FOIL and expand and simplify. You'll see here that you have 6.3t plus 13.86 minus 6.3t. The 6.3t's cancel out, leaving the final equation to be 13.86 over t plus 2.2 to the power of 2. That is our first derivative equation. Now that we have the equation for the first derivative, we can solve the problem. The problem asks us to find the rate of change at 6 seconds. That means t, or time, is equal to 6. We can now sub this in and get our answer. Therefore, the mass is changing at a rate of 0.206 grams per second after 6 seconds. Part B says, is the rate of change of the mass ever negative? Explain. The key pieces of information we need to know from here is that we're going to be analyzing the rate of change of mass. For this, we'll need the givens from before, as well as the first derivative equation that we solved for in Part A. The question asks if the rate of change could ever be negative. My plan to solve this problem is to focus on the first derivative. I'm able to do this because rate of change is a measure of slope, instantaneously, and the first derivative is a measure of slope, instantaneously. Therefore, you can see how the first derivative and instantaneous rate of change are interchangeable. They're both measures of slope and will give the same number. That allows me to focus on the first derivative. The first derivative equation from question A is this. We can see that the 13.86 is a constant and will always be that number. That means it's always going to be a positive divided by the denominator. The only way for this to be a negative answer is if the denominator is negative. So my goal is to focus on the bottom number and see if it's possible to be a negative. That would result in a positive divided by a negative, resulting in a negative answer. There are 2 main reasons why the rate of change can never be negative. The first reason is the variable. In this case, in the context of the question, the variable t represents time. Since there's no such thing as negative time, this bracket will always be a positive number, and multiplied by itself will remain positive. Therefore, the equation will be a positive divided by a positive, which is obviously going to result in a positive answer. The second reason is the exponent. Even if this bracket somehow managed to be negative, it will multiply by itself and again become positive, resulting in a positive divided by a positive, therefore a positive answer. Therefore, no, the rate of change of mass will never be negative. Concepts like first derivatives and rate of change are used in everyday careers, a couple being chemists and environmentalists. An environmentalist might use these concepts to determine how long it would take a banana peel to disintegrate in the earth, or how long it would take the rain to evaporate. A chemist could use these concepts to determine what mass a sample will be after a certain amount of time, or how long a reaction will take to reach a certain mass. There are many other examples and many other careers that use these type of concepts.